Hi, my name is Derek Weitzel, and today I'll be talking about the Science Gateway for Biological Nanotechnology. So first, I'm an assistant research professor in computer science. I work with researchers at UNL and on the Open Science Grid to enhance their science and their research with computational resources. And I'll be working with, or will be connecting with, Dr. Joseph Yesselman, and he's an assistant professor in chemistry. He's interested in the structural basis of RNA functions and how to design RNA nanostructures and machines. So first, HCC is the Holland Computing Center. It's Nebraska's research computing resource, and it's also available at hcc.unl.edu. It provides Nebraska's researchers with computational, storage, and other resources. And I have two pictures here, one with one of our system administrators and our supercomputer, which is in the basement of the Shore Center. And then we also have a visualization services, and this is one of the visualizations that we routinely run. We have the emerging field of RNA nanotechnology. RNA nanotechnology promises to create nanomachines to revolutionize things such as engineering of materials and catalysts, biomedical diagnostics, and therapeutics. And on this slide, you'll see some examples of how RNA machines can provide function. In order to create RNA nanotechnology, it requires precise control of RNA structures. So you have to assemble these RNA nanostructures in a very specific way, and you have to simulate it. Now, the Yesselman lab, led by Joseph Yesselman, generated a suite of software called RNAMake that can automatically assemble these new nanostructures. And RNAMake is the software that will be the processing for this gateway that we are proposing. So RNAMake is this powerful tool for designing RNA nanostructures and machines. And so it's actually able to model and get very close to the actual structure. It can do many different types of modeling, all within the computation on a supercomputer. So a gateway is a user interface for scientists to use research resources, such as computing and or storage. So the goal is to provide an easy-to-use interface for researchers, and the results should be presented to the user in a format that's readable and usable. So for example, the output should be not only visualized in the example of RNAMake, very similar to how these pictures look, but also that the format should be downloadable in formats that are useful for secondary processing if necessary. So an example of a gateway, and this is a BLAST gateway from the National Institutes of Health. You're able to input parameters and include even some files, and the processing is done on some back-end servers or cloud. The user doesn't care where it runs. And once it's completed, you get the results emailed to you, or you get a link back to the website with the results. This is an example of an existing science gateway hosted by the Holland Computing Center called CPAS. As you'll notice, the front page describes the workflow. You're able to register and log in on the right. When you log in, it'll take you to CI Logon, and you're able to choose your identity provider. I will use the University of Nebraska-Lincoln. It'll take you to the UNL login, including two-factor, where you can finally get to submitting a job, including uploading files that may be needed, some parameters, and then you're able to submit. You can also check your job status here as well. So we have a current gateway. It's limited that it can only run on a single node. We want a new gateway which will run on HCC's supercomputers and on the Open Science Grid. We have an existing application, RNAMake, which I've discussed, which takes known input and known output. We know how this application works, and we want to create this infrastructure around this application. So this new gateway, we won't prescribe technology, so technology sources are your own. There are some gateway frameworks such as Apache Arvada and Agave, that are used to create these science gateway frameworks. There's a large organization that can help answer questions on science gateways and technologies called sciencegateways.org. And no matter what framework is used, this project will no doubt require modern web technologies. So I would not be surprised if there is quite a bit of JavaScript that will have to be written and those type of languages. A new workflow will also need to be created. We recommend, but we're not prescribing it, that the execution is managed by Pegasus. Now, it handles the data movement and workflow mechanics on behalf of the user, and Pegasus you can easily describe a workflow, and Pegasus will adapt it to either running on Holland Computing Center, on other supercomputers, or even on distributed grids such as the Open Science Grid. So the objectives and deliverables for this project is a web gateway to submit the processing. We would like some sort of federated login, such as in Common, a home page with a description of the workflow, submission page, processing status page, results, and then also we would like an email when the results are completed and a link to the results page. For the workflow, we need some sort of workflow manager, such as Pegasus, that will run the RNAMake application. It must be able to run on Holland Computing Center, but in addition, we'd like it to run on the Open Science Grid. Now, this executable RNAMake is provided, and we'll also show you how to use it. Thank you.